Hey all, Andre Freeman here. This video will show the process of performing a hypothesis test for a population proportion. Let's look at question 4. This is in the practice assignments in module 8 in the last set of assignments, or the last assignment. A well-known brokerage firm executive claimed that 20% of investors are currently confident of meeting their investment goals. An XYZ investor optimism survey conducted over a 2-week period found that in a sample of 500 people, 26% of them said they are confident of meeting their goals. Test the claim that the proportion of people who are confident is larger than 20% at the 10% significance level. So the claim here, or that we're going to focus on, is the claim is that the population proportion is larger than 20%. So what we can do is we can think of that as saying that our claim is that P is greater than the 0.20. So based on this, we're going to get two hypotheses. The null hypothesis would be that the population proportion equals 20%. And the alternative hypothesis would be that the population proportion is greater than 20%. And notice that the values in the null and alternative hypothesis are always, of course, the same number. So the alternative hypothesis is based on the claim that we're trying to investigate, and the null has an equal sign. Because we have a greater than symbol in the alternative hypothesis, we're going to do a right tail test. So what we can do now is we can prepare to calculate the standardized test statistics. So this is going to be the z-score of the observed sample proportion. So we're going to do sample proportion minus the population proportion, which we get from the null hypothesis, and we divide that by the square root. The population proportion I'm going to just put as P. We're going to divide that by the square root of P times 1 minus P, and this whole thing divided by N. So this is the calculation that we use to get a z-score of the observed sample proportion. Let's take a look at our sample proportion. It says that in a sample of 500 people, 26% of them said they are confident of meeting their goals. So in this problem, the sample proportion is 26%, which is 0.26. The hypotheses that are correct here are the first group. The null is that the population proportion equals 0.2. The alternative, which is here H sub 1, is that the population proportion is greater than 0.2. This is going to be a right tail test. Let's now compute the standardized test statistic. So that's going to be this formula here. So let's do it. So we have Z equals, the sample proportion is 0.26. The population proportion is 0.2, and then we divide by the square root of that. So square root of 0.2, 1 minus 0.2, divided by the sample size. Let's check again. The sample size is 500 people. So we divide by 500. Okay, so we're getting a z-score here of 3.354. So this z-score is very large, which tells us that the sample proportion of 0.26 is very unusual if the population proportion is truly 0.2. So already we're getting a sense based on the z-score that the population proportion may not actually be 0.2. So the null hypothesis may actually be false, in which case we should reject it. But let's continue with the process. So we have a test statistic of 3.354, and now we're going to find the p-value. So the p-value, because we have a right tail test, is going to be the area to the right of the z-score. We're going to find the area to the right of the z-score. So since we're finding the area to the right of the z-score, we're going to use a normal distribution. So let's go to the normal distribution app here in DCMP, and we can quickly find our p-value. The p-value is going to be, again, the area to the right of 3.354. So this is our z-score corresponding to this sample proportion. Let's find the area to the right of this z-score. So here we'll go find probability. We'll do a greater than, and we'll do 3.354. And this area to the right here is our p-value. So let's see what it is down here. This is a very low number. This is 0.03983%, but we have to move the decimal point over 2 places. So this number as a decimal, we're going to add 2 zeros in front of this initial 0. So we'll have the decimal of, so this is 0.0398%. So when we add the 2 zeros in front, we get 0.00398, and this is our p-value, which is the area to the right. That's correct. There should be 3 zeros before the 3. One more 0 here. Okay, so this is our p-value, which is basically 0.0004. So this is a very low p-value, which tells us that the sample proportion of 0.26 is very unlikely if the population proportion is truly 0.2. More specifically, we can say that if we assume the population proportion is 0.2, there is a 0.0004% chance, or there's a probability of 0.0004 that we get a sample proportion of 0.26 or higher. This is a right tail test. So here we can now enter in 0.0004. That's our p-value. The p-value is less than the significance level of 10%, so we're going to reject the null hypothesis. All right, guys, I hope this helps. And make sure that you are using the right probability distribution based on the type of test you're performing.